All right, so we are skipping a little bit. That area lesson, we'll probably go back to that tomorrow. Well, no, not tomorrow. What did I say? Friday. So we're going to do law cosines today, and then tomorrow we're going to do the law of sines. They're both under 12.6, so I probably could have called this 12.6a, if you want to call it that. Okay. All right, everybody good? All right. Well, you know what cosine means, right? Somebody get the door. What does it mean for the cosine? Like if I said, what is the cosine of an angle? Cosine of angle A, what would I say? Yeah, it's adjacent over hypotenuse, okay? We're not really going to use that in this one, but we already know a little bit about the cosine. Well, that really doesn't deal with what we're doing today. What if... You know what? I was just trying to think of like a little backstory to tell to get to where we're going to be. I'm just going to show you right off the bat. Is that all right? Yeah. So what if I had a triangle and it's not necessarily a right triangle? That may look like a right triangle, but we'll say it's not. Is that all right? Would you say it doesn't look like one? Yeah, that kind of looks pretty close to one, but we'll say it's not. Who knows, 85 degrees, 92 degrees, okay? It's not a right angle, right? And they're going to give you some information, and you're going to have to solve for some stuff. We'll call this A, C, and B. Call this angle A, angle B, and angle C. Now, there are no right angles in here. There are no right angles. Don't know why I'm writing uphill, but it says no right angles. All right, so we have to have a method to be able to solve for some missing sides, missing angles, depending on what they give us. All right, I'm just going to show it to you right away. They do a little proof of it before it says in the book, law of cosines. You got this green box, says law of cosines. There's 3 things in it. And then before that, they kind of do a proof, show you how they get to this. I just decided today, it's a short class period today anyway because it's Wednesday, that we would just show you what it is. All right, so let's say you were trying to solve for this, okay, C, and you knew you knew side A, you knew side B, and you know angle A. Is that all right? Let's put those in different colors then. Oops. So let's say they tell you that. Oops, why didn't it turn red? Let's try this again. There we go. All right, so let's say you knew what angle A was. It's some number, all right? And we're going to do an example, all right? So we'll put the number in there eventually. And you knew what angle B was, and you know what angle C was. All right? So let's say they give you all that, but you have to find side C and angle A and angle B. Now remember, you know what angle A is. I'm sorry, why I keep messing up my letters? You know what angle C is right here, don't you? All right. Is there any way, since you know angle C, that you know of in order to find angle B and angle A? There's not. You can't use sine, you can't use cosine, you can't use tangent. Why not? Because it's not a right triangle. Very good. Okay, because, oops, everything's messing up. Okay, it's not, or there are no right angles in this. Okay, this is not a right triangle. All right, so you can't just use your regular sine, cosine, and tangent to find some missing stuff. Right, because to do those trig things, you had to have a right triangle. But now you have a non-right triangle. And there are times, depending on what information they give you, there are times when you can use the law of cosines. You can't use it every single time, but if they give you these 2 sides and this angle right here, you should be able to find this side C. And, well, at least, let's just say it this way. You will be able to find angle C. Once we know the law of sines and the law of cosines, then we're going to put it all together and we're going to be able to find everything. And let me just see this. Where'd they get? I'm looking at one of the examples to see something here. Angle A, cosine. Oh, okay, cosine C. Yeah, this is what I get for not doing my writing down the lesson. I thought I had this done because I taught this last year, and I thought I had lesson 12 all written out, but I guess I don't. So let's just do this first one. This is pretty easy. What we're going to do looks very, very similar to a Pythagorean theorem. Okay, but again, Pythagorean theorem, what kind of a triangle do we need to do Pythagorean theorem? A right triangle, okay? So we can't use Pythagorean theorem, but this is really, the first part of it looks almost identical. Well, it is identical to the Pythagorean theorem. So if I start with C, what would the Pythagorean theorem be? C squared equals what? A squared plus B squared. But the law of cosines has a little bit of extra added stuff on the end, okay? So here's the new stuff. So you know that, okay? Here's what we have. We got a minus, and then we got a 2ab cosine of C. Now let's talk about this. This is a lowercase c, lowercase a, and b, which means what? What does it represent over here on this triangle? The what? The angles or the sides? The sides. If it's lowercase, it represents the sides. So this is side C, this is side A, this is side B. Everybody with me? All right, minus 2, you know what that is, it's just a 2. And then the A and a B again, okay? It's the same number that's being squared here, okay? So whatever your A is, you put right here. Whatever your B is, you're going to put right there. Everybody with me? And then you're going to take the cosine of, what do you think this is? This is an angle, right? This is angle C. See how the C is bigger than the C? And plus, you can only take the cosine of an angle anyway, correct? Can't take the cosine of a side. Everybody understand that? You can only take the cosine of an angle. So this has to be an angle right here. So that, most of the time, teachers just leave it like that and say that's your law of cosines if you're trying to find side C. All right, so given A and B and given angle C, this is what we're gonna use. Everybody understand that? Yes, Samara. Good question. And we're going to write those down. So that was exactly what I was going to get to. So you're following right along. So what if you didn't know A, but you know B and C? So what would you do here? If you had to solve for A, you'd put that on the end and square it. What are these going to be right here? You already used the A, so what's left over? The B and the C, right? Okay, so we'll put it in alphabetical order. We'll just go B squared plus C squared minus, what do we do here? Minus 2. Instead of AB, what's it going to be? B and C. Everybody see that? And then the cosine of what? Is it going to be angle C? Angle A. Very good, because look, this is angle C. This is side C. Whatever you put here, the angle is going to be the angle opposite that side. So if you're solving for side A, what are you going to take the cosine of? You're going to take the cosine of angle A. So that's another way that you could write it. Really, it's all the same thing. Okay? It's this side and this angle are opposite each other. These are your leftover sides, and these are your leftover sides. Does that make sense? So you could write it another way. Tell you what, let's put this in a box. Now you're kind of getting the idea, right? How could you, what else could we solve for? We solve for C on this equation. We solve for A on this equation. What are we going to do here? Solve for B, right? Side C, side A, what's left over? Side B. So I'm going to go B squared equals, now I'm solving for B, so what am I going to do with these two sides? Square them and add them up. So let's go A squared plus C squared. And it's not like you have to remember all three of these. I would just remember this one. That's the main one that we're going to remember. But I'm just showing you all three of them. They show it to you in the book. So I figure I'll show it to you here. What's this going to be? 2 AC. Good. And then you're going to take the cosine of what angle? Angle B, because it's always the angle opposite this side right here. So there's 3 ways you could look at it. All right, but they're all really the same thing. All right? It's this first one that we normally say. Like if I stop somebody on the street, providing they know the law of cosines, if I stop somebody on the street and said, hey, give me the formula for the law of cosines, most times they would say c squared equals a squared plus b squared minus 2ab cosine c. All right? Yeah, you might be a while before you find somebody on the street and you ask them what the law of cosines is until you find somebody that actually knows it. But anyway, that was just more of a joke than anything. But that's what we want to remember right there. Okay? So it's kind of close to Pythagorean theorem, but you got that little bit of extra stuff right there. You think you can remember that little extra stuff? Yeah. And obviously, why do they call it the law of cosines? Because the only trig function in here is cosine, right? So that's why they call it the law of cosines. But we can use this with non-right triangles. This is the first time in trig that we've used non-right triangles. Everything we've done so far, we haven't done that much. We've only done 2 lessons, but everything we've done so far, we've used right triangles. All right, ready for an example? Wow, that was a lack of a response, wasn't it? Say, yeah, let's do an example. All right, so here you go. Here's a triangle. Again, I don't know why. Every time I make a triangle, it seems like it's a right triangle, but it doesn't have to be. Here's what they give you. They give you 6. They give you A. They give you 9. Whoops, it looks like an A. That's a 9. They give you this, 57 degrees, and that's all they give you. Call this C, call this B, call this A. All right, and they want you to solve for A. Solve for side A. Oh, I see what they're doing. Okay, here we go. Everybody ready? Now, remember I learned c squared equals a squared plus b squared, but really what do you find in here? You find an A. All right, so how are you going to write it? You're going to write it a squared equals what? B squared plus C squared minus 2 BC times the cosine of what? A. All right, so that's the one that we're going to use. Now, look, they could give you a triangle. They could put X, Y, and Z in there. All right, and you're like, well, Mr. Hamrick, you didn't teach us how to do X, Y, and Z, but isn't the same exact thing, right? You just pick which one you want to. I mean, I could have called this one C if I wanted to, couldn't I? All right, and I could have called this angle C right here, just rearranged it. Wouldn't have been that big of a deal. All right, but that's how we would do this. So that's why we showed all 3 of them. So that's what you're going to use. So let's plug stuff in, right? We got everything we need to be able to solve for A. So, but do we know A? No. So I'm going to write A squared. Do I know B? Yeah. And does it really matter if I call this one B or if I call this one B? It's not going to make any difference because I'm just adding them up. Right here, I'm just multiplying them. So it doesn't matter the order. But we might as well just put it in the right order. So what is side B in this triangle? It's 6. Right? Here's angle B. This is side B. What is 9? Side C. All right? So let's plug everything in. 6 squared plus C, which is 9 squared, minus 2 times B, which is 6, times C, which is 9, times the cosine of angle A. Remember, this angle has to be opposite of the one that you're solving for. So it is, isn't it? So it's 57 degrees, cosine of 57 degrees. And now, all you got to do is put that in your calculator. Now, this takes a little practice, all right? You must you must practice putting this into a calculator. Just because I hand you a calculator and I give you this and say, okay, get A, doesn't mean you're going to get it. All right, so make sure that you're very, very careful. So I'll bring the calculator up. Round to whatever they tell you. If they don't tell you, nearest tenth is good. Yeah, don't round it to the nearest just regular number. It's best to round to the nearest tenth. All right, so I need to do what? Change it to degrees. Enter. All right. So if you're watching this on YouTube, you won't be able to see the calculator. Sorry about that, but you can practice putting it in yourself. So if you wanted to, you could put a big old square root, because to get A by itself, we'd have to get rid of that squared, right? So I would square root this whole thing. So technically, this is what you're putting into a calculator, all right? Now, it depends which calculator you're using. Have you heard that before? Seems like I'm saying that every class period. I did that to my my CP geometry kids. I was like, make sure you know how to use your calculator. Today, they took a quiz. Not trying to slam on or anything, but I'm just explaining to you that I told them yesterday, get your calculator out. Make sure you know how to use your calculator. They had to do square roots, right, of stuff. And I was like, make sure you know how to do the square root button. You wouldn't believe how many people asked me, Mr. Himmer, I got the good calculator. I don't know how to do square root. I'm like, you were supposed to do it yesterday. You were supposed to practice it yesterday. And they didn't. Most of them had their head down. Anyway, what can you do? So, I don't know. So, on a calculator like this, I'm going to show you. Unfortunately, I've looked and looked for a calculator that goes on the computer like this. That's just a regular scientific calculator, right? That many of you guys have. And I just can't find one. So I'll use this one, and then I'll try to talk you through doing this with a regular scientific calculator. So here's what I'm going to do. Put a big old square root. So there's a square root, and then we're going to put the numbers in. So I go 6 squared plus 9 squared. Now, I don't know if you need it, but I'm going to put it. Okay, I'll probably put a whole bunch of parentheses here. All right, so I'm going to close that parentheses. Everybody see that? I don't know. I just feel safer doing it that way. All right, so that's what I'm going to do. Then I'm going to put minus. And then look, all this stuff is being multiplied, isn't it? So guess what I'm going to do first here? I'm going to put a parentheses. Everybody with me on that? Okay. And really, you know what? I should have 2 parentheses here. One parentheses that puts all that into the square root. So let's do that. I think I can put it in here. Oops. Oh, now I got to put it all. I thought it would just stick it right in there, but it doesn't. That's okay. Let's do it again. 6 squared plus 9 squared. 9 squared. Close the parentheses. Minus another parentheses. There we go. Do you see why I put 2 there? Because I'm putting one parentheses to group those. I'm putting another parentheses to group those. But then I want to group that whole thing under the square root. So I'm going to have 2 parentheses there. Make sense? All right. So this one just groups that together. This first one will group everything under the square root. All right. So minus what? 2 times 6 times 9. And then you don't even have to put a times. You can just put cosine of 57. Now I'm going to close that parentheses, that 57 parentheses. But now I need another one. Why do I need another one? For that, see that parentheses right there? And then I need one more. Let's hope this works.
You didn't close out the 2 times 6.
Well, yeah, I did right there. See that this 57 is in that parentheses. When we wrote it, we didn't have to put a parentheses around it when we write it like that, but the calculator automatically puts that first parentheses there. So here's that first parentheses. Here's the one that groups all this together, right? That second one right there. Then we're going to put one more, and then hopefully that works. Okay, 7.62. Yay, it works. And they did round it to the first decimal place. Okay. Yeah, they did. I'm looking at it. So to solve for A, they rounded it to one decimal place, which is 7.6. Can be a little confusing. There may be a possibility of not having to do all this, some of these parentheses, but to me it just kind of makes sense. You can try it. All right? There it is. What you need to do is make sure that whatever calculator you use for a quiz and test, you're practicing with right now, and then when you put all those numbers in, you get 7.6. Here's what I would do if I was using just a regular scientific calculator. And that's what I usually use. I don't really use the graphing calculator all that much. So I can't really show you the calculator on the screen, but I will put some parentheses there, show you what you can do. Now the book is kind of doing it like I'm going to do it right now. So watch. Here's what I would do if I was using a regular scientific calculator without graphing and all that. Do you remember me showing you that? See if it looks like this with just one line, right? If you have two lines or more, what I mean by lines, you see this line right here, this one right here. See, that's more than two lines, right? So if you have more than one line, you probably do it the way we did it on this graphing calculator. If you only have one line on the top of your calculator, right, and you don't have any more than that, it just goes here, this is probably how you do it. Here's what I would do. I would go 6 squared plus 9 squared, okay, minus, and then I would put a parentheses. Then I'd go 2 times 6 times 9, and then on a scientific calculator, I believe you have to hit times cosine of 57. On this calculator, you didn't have to. You just write down cosine after the 9. If you have a regular scientific calculator, you need to put a times in there. You see that? And times 57. Then what you do is this. Then you hit the parentheses. What that's going to give you, once you hit that parentheses, it's going to give you the value in that parentheses. So then you have to hit equals. What's that going to give you? When you hit equals, that's going to give you, whoops, messed up my little thingy here. That's going to give you that whole thing right there. But we still have to do what? You still got to hit the square root button. So if you have a regular scientific calculator, who's got one? I'm just curious. If you just have one with one line, all right, so make sure you get this. Make sure you get 7.6. So did you get it? Have you tried it yet? All right, so 6 squared plus 9 squared minus parentheses 2 times 6 times 9 times cosine of 57. Close the parentheses, hit equals, and then you take the square root, and you should get 7.6. Okay? Has everybody tried it? Yes? Everybody promise me? Has everybody tried it and got 7.6? Okay? You got to make sure you do that. You should have your calculator with you all the time. Do you? All right. So, there you go. Everybody good with that? When are we out of here? 40-something, right? Is it 40? Oh, 28. 28? Is that right? Wow. I got 28 on my count, my thing. Yeah, 28. Okay. All right, let's do one more. Let's do one more example. Now, here's the deal. Let's move this calculator out of the way. Okay. Watch this one. This one. Can you what? Can you leave when you're supposed to leave? Like when? When? 1:20? Okay. All right. That's all I needed to know what time it was. All right. Here's another one. Everybody ready? And kind of looks like this, kind of looks like this. Again, I don't know why every single triangle I draw looks like a right triangle, but it still looks like one. But it's not. This is 78 degrees. That's not a right angle. And this side is 6. And this side is 5. And this time, yeah. All right, to find C, it shouldn't be that hard. All right? So let's put it in here. So C squared equals A squared and B squared. Okay, either one of these could be A or B. It doesn't make any difference. So I'm just going to go 6 squared plus 5 squared minus 2 times 6 times 5 times the cosine of the angle. What's the angle I'm using? 78 degrees. Remember, that angle has to be opposite this side right here. Everybody see that? All right, make sure that you do that. And then they already got that in there, I think. Yes. 6.97. If I round 6.97 to the nearest tenth, what is that? 6.7? It's just 7. 7 point what? We got to have a tenth place in there. 7.0, right? See that? The 7 rounds the 9 up, 1, right? Which makes that a what? A 10. Where do you put the 1? You put it right there. You make that a 10. Everybody see that? 6 and 1 is 7.0. So 7.0 is rounded to the nearest tenth. Just don't put 7. All right? 7 is not rounded to the nearest tenth, is it? No. All right? 7.0. I know what you're thinking. 7.0 is the same thing as 7. Well, it kind of is. It's kind of not. Okay? All right? So anyway, I'm not going to get into that. This is not the time. Now what we want to do is solve for the other sides. So if this is angle C, we'll call that, if that's side C, we'll call this angle C. And we'll call this angle A. We'll call this angle B. So this is side B, and this is side A. Okay? What we got to do now, what we haven't done before, is to solve for A and B now. But we know what C is, don't we? We know C is 7.0. Now, on a calculator, you can just put in a 7. It wouldn't be any different. So now what do we have to do? What we can do now is actually solve for angle A, can't we? Can we do that? Yeah, so let's do that. Now, the thing is, I'm going to have to find the angle. The two examples we've done so far, they gave us this angle, didn't they? So there's a little bit of tricky algebra involved, but our setup is the same. So this time, we're not going to put A squared. What are we going to put? 5 squared. Is that what you said? Yeah. It seems like everybody whispers, or I just can't hear. I think it's a little bit of whispering and a little bit of me not being able to hear, but you got to speak up. All right, so it's 5 squared equals the other two sides squared and added up. So what would that be? 6 squared plus, yeah, we don't really need the 0.0 now, okay, because, don't worry about it. You're just being contrary, all right? So it's 2 times what? 6 times 7. Notice, these two numbers are always the same as these two numbers, right? Cosine of what? Of A. So this time we have to solve for A. Now watch very carefully. I only got 3 minutes left. Everybody watching? I have to get this by itself. So the first thing I'm going to do is get rid of the 6 squared and the 7 squared. How do I do that? No, I'm not canceling. I can't just cancel. What do I do to cancel them out? Do I add, subtract, multiply, divide? What do I do? How do I get rid of this 6 squared? Yeah, subtract it. Very good. Just subtract it, okay? So I subtract a 6 squared here, and I subtract a 7 squared. I do it to both sides. So guess what I'm going to have? I'm going to have a 5 squared, which is already over there. Move this over, minus 6 squared. Move this over, minus 7 squared. Everybody see that? Now they cancel out. I'm not going to actually put minus 6 squared here. You can do that in your head, can't you? And you know it's going to go away. Now what do I want to get rid of? Again, I'm trying to get A by itself. Yep, it's a negative 2. These are all being multiplied, correct? All this is being multiplied. So how do I get rid of stuff that's being multiplied? I divide it. So I'm going to divide it. You know, they're all going to cancel out. Okay, but I got to divide this side. So what am I going to get? Negative 2 times 6 times 7. So that canceled, that canceled, that canceled. Now, here's something that I think they should have taught you. I don't think we've done yet. Did we do the inverse cosine, inverse sine? We did cosine to the negative first. Okay, they did teach it to you. Again, like I said, I'm teaching trig to 3 different classes. I can't remember which ones we've done. So if I want to get a by itself, I got to get rid of the cosine. How do I get rid of the cosine? By taking the inverse cosine. So that'll get rid of this, and then I come over here and I do the inverse cosine of all of this. Okay? So this is what we're putting into a calculator. I told you that algebra was a little bit tricky, but it wasn't really that hard, was it? No, I subtracted a couple things, divided these 3 things, took the inverse. So really 3 steps, and you got a by itself. So now you got to put all that into a calculator. So let's bring this trusty calculator over again. So what am I going to do? Let's turn it back on. So I'm going to hit inverse cosine this time. So second function cosine. And then I'm probably going to put another parentheses there. All right, because I want to get the top and I want to get the bottom. So this second parentheses means I'm going to put all this stuff up here in that parentheses. So I've got 5 squared minus 6 squared minus 7 squared. Then I'm going to close that parentheses. What's that?
Is the rule 5 and anything above being rounded?
Yeah, 5 or above. Yeah, let's not worry about rounding. Let's do this. Okay, so now I put divided by, and now I'm going to put another parentheses. See that? I'm putting this in a parentheses, and I put that in a parentheses. All right, so divided by parentheses, negative 2 times 6 times 7. Close that parentheses on the bottom, correct? Now put another parentheses. This big parentheses right here would be my last parentheses, and then I hit enter, and boom, 44.4 degrees. And that should be, let me check. Well, they put, yeah, I kind of know why. Oh, you know what they did? For that 7, now why would they do that? They put 6.97 in, so my number's a little bit different. So we got 44, so we got A is 44.4 degrees, and that's perfectly fine, okay? So watch this. So A is 44.4 degrees. Without doing any of the law cosines, how can I find angle B? Add them together, take them from 180. So it's 180 minus these 2, and then that'll give you whatever that is. What would that be? 150. Can I do that in my head?
I don't know why you would do it.
No, it'd be 57.50. Whatever that is. Okay. All right. I can't do that in my head. But anyway, whatever that is when you subtract it from there. Does that make sense? So that's law cosines. So I only gave you like what? Everybody's leaving? Where's everybody going?
Oh, is it the homework? Wait, can I take a picture?
The homework is 1 through 6. Okay, so you're only doing 1 through 6. So 1 through 6. 55.6, is that what it is? All right, I'll take your word for it.
You shouldn't.
I shouldn't. I think it's 54.6. But anyway, it's something. All right, so it's 1 through 6 is your homework.
1 through 6.
That's it.
I'm luckier than that. Wait,
Look at the problem they had to do.
I'm not.
Have you seen that before?
I was
Have you seen these 3 things before?
Yeah.
Okay, you have?
Yeah, we did last year, right?
Oh, we did? Oh, we did it last year, didn't we?
Geometry.
Okay, yeah. So anyway, I probably gave you 1 through 6 last year, so don't complain.